Hello everyone. Today in the series of lecture of cognitive ergonomics, we are going to have lecture 2, Introduction to Cognitive Ergonomics. As we studied in the previous lecture what cognitive ergonomics means, and as it is comprised of two words, cognitive plus ergonomics, we take this lecture forward and understand in detail some of its application and its impact. So, cognitive ergonomics not only is providing an insight to us about the organizational setting, cooperative work, user interface design, how the user is interacting with different interfaces in the modern era, modeling of the users and the systems. Recently, we have seen technological problem has emerged out immensely. So, different solutions are required. Learning about a system and its design has created its own challenges. The design of automation itself is providing its own challenge. So, cognitive ergonomic can provide us and may help us not only in the reduction of negative situations but also can promote the performance, efficiency, safety, and user satisfaction. So, as we discussed in the previous lecture, identification of the negative situation, what those negative situations are, and how one is defining the problem and the consequences as a result of this problem. There are several ways in which the problem can be defined and one can avoid and reduce its impact. So, we need to study and investigate in cognitive ergonomics how the mind works. So, let us take an example. In this cartoon, what you see, an aviation example where a plane is crashed. The plane which you are seeing here is crashed. There could be several failures towards it. One such failure could be an human error, another failure could be an automation. Now, the plane dates back to World War II, and there were several plane crashes during that time period. As we took the example in our first lecture about the landing gear and flying gear. The proximity of these two buttons were resulting into the plane crashes. And very soon, the ergonomists figured out this is the failure in the system itself. The moment they rectified this problem, the plane crashes decreased. But in the field of aviation, there are a number of challenges which a pilot faces. And then the coordination with the air traffic controller. In addition to that, the skill and abilities of the pilot is also involved here. What we see here on this cartoon, that the human cause of aviation failure or the error in aviation is inversely proportional to its technical causes. As the human error increases, technical difficulties and challenges are little less in nature. So, these two parameters are inversely proportional to each other, and as you can see on your graph, the y-axis shows the number of accidents. Increase in number of accidents are due to human error. But this is from 1903 till present period. Now, modern technology, modern automation, all these things providing an aid to reduce human error, but if still these things are happening, these incidents are happening, then it is important for us to understand the reason behind it. And that is what human factor is trying to investigate. And in this vast domain of human factor, there are different subdisciplines such as physical ergonomic, psychological ergonomic, cognitive ergonomic, etc. We are more concerned in this lecture series about the human cognition and its role in ergonomics. So if we move further, you can see on your screen, this is a chart which reflects about the biocircadian cycle of an individual. And on top of this chart, you can see there are several incidents which occurred at different time frame. On the y-axis, you can see the change in an hour, and roughly it is about 24 hours changes. And on your x-axis, there is a time window. So what you see here, most of these accidents which are piling up is happening during the midnight, particularly and roughly around 1 am to 3 am. The increase in human error is happening during the shifting hours also, when the people are shifting. And that is why in the modern world we have a 3-shift working routine, 8 hours of work shift. People start working from 8 o'clock to 2, then 2 to 10, and then 10 to 6 again. This is how the cycle works, and it clearly reflects that if the human errors are there, if there is a compromise with the performance, efficiency, safety, satisfaction, then biocircadian cycle also plays a major role in it. How one can reduce such errors? Maybe controlling and channeling the work shifts. So the contributor to human error can be a stress, physical stress, psychological stress, cognitive stress. Someone is involved in solving a tedious and a complicated mathematical problem. Someone is involved in writing a poetry. Someone is involved in completing and meeting its deadline for filing a report. All these things can lead towards stress. Another factor is the boredom. When a person is too much working and engaged in a task but didn't find a time for pleasure or enjoyment or socializing, then it leads towards the boredom. Sometimes the work itself can facilitate the boredom. Sometimes monotonous actions also leads towards boredom. So this is another contributor to human error. People do not find excitement in their own work. As a result, the chances of error is high. Substance abuse is another contributor in human error. Recent studies have highlighted that a substance abuse can not only affect your performance and efficiency, but it may lead into severe incidents and accidents. And that is why at workplace setting, such substance abuses have been strictly prohibited, and under guidelines or rules and regulation, these are forbidden at the workplace setting. Another contributor is disturbing the biological clock, which is the biocircadian cycle. As I was telling you in the previous slide, that how our circadian cycle get altered, and this alteration in biocircadian cycle result into human error. Some people have tendency to work at night. Some people have tendency to work early morning. Some people have tendency to work late afternoon. But we have our biological limitation. At night time, we have to sleep, and during the daytime, we have to work. Our body, our biological mechanism also requires some resting. But when this irregularity or imbalance happens in our biological cycle, then human error occurs. Then another contributor is the fallibility of the groups. Different groups, different organizations, different people are there. We try to adjust ourselves but failure to be part of it, failure to be accepted result into it. It should be noted here that there are many more there are many more contributors are there which leads towards human error. For details for other human error contributors, we may be addressing it in coming lectures. But here these are the 5 major contributors towards human error. Now, when we talk about a cycle of human factor, what we see here is that there are 2 systems which are being involved here. One is the human and one is the system. Now 40-50 years ago, the system people were calling it as a machine, so human machine system. Now today the system which we are highly using it is the computer. So human computer system can also be seen as. System can be any body through which we are interacting to. The interaction with the system results into an output which we measure it as a performance in the form of a performance. Now when the interaction happens, this interaction is supposed to identify the problem, what the problem are. The problem could be, a number of problems could be there. It is important for us to classify the problem. It is important for us to categorize the problem. In a cycle of human factor, the first stage is the identification of problem. There should not be any limitation to the identification of problem. One should be identifying the problem in a detailed way. One could end up with one problem, another could end up with 100 problems. There is no harm in the number of problems. More number of problems we identify, the better the approach is going to be to solve the existing problem. Now, second stage is to find the solution related to the problems, and in some cases the individual may find some solution, few solutions or none solutions, but it is always suggested in the human factor to approach the problem in a very basic form, to provide a solution in a very basic form. The moment we have identified the problem, we have found a half solution. So once the solution is, we started to document and start compiling it, then the stage comes, the solution, the best optimal solution to implement. Now the optimal solution can be a tricky question. So at this time, let us not address the optimal solution, but at least what we can address is finding a solution, and finding any solution towards a specific problem, let us implement it. What may happen that the design may work, and this redesigning with the new solution may help us to solve the problem. Now when we talk about the design, an equipment may be involved, a hardware, the task can be involved which could be related to a software in the case of human computer interaction, the environment in which we are working, the context, the selection of the task itself, what kind of task and response we are selecting to, and the training associated with it. More number of training is there, better way to solve a problem, existing problem. Less number of training is there, it may have its own challenges. Once the solution has been implemented and the changes are being seen in the design, redesign, then it feeds back again to the human system. Now humans parallel to that trying to analyze different other techniques. What has not been explored in this human system is the interaction between the two. Humans, when we talk about human beings, then it can be split into two parts. One is the brain and another is the body. Brain and body coordination in the human beings directly and indirectly influences the human machine interaction or human system interaction. This discipline, where the amalgamation of brain and body is happening, has been less explored in the human factor discipline. Understanding such coordination between the brain and body to address the interaction system is something which is required at the current era. Now, this may provide us an insight, the limitations, the challenges, the advantages of human beings in human factor. Now, there are a number of parameters and variables also playing role. When at one hand classical ergonomics were only looking at the quality of working, it increased and it raised several concerns that if human factor is only and only about the quality of working, if that is the case, then human beings, the workers, the employees may face several challenges and it ultimately affects the work. Nobody is going to work in an organization where he or she is not being appreciated. Nobody is going to work in an organization for 30-40 years without being appreciated. So, and it has been seen and it has been reported also, the quality of work decreases over a period of time. If an employee, an older employee who stays in an organization more than 30 years, his efficiency, his performance, his quality of work seems to be less than those employees who have been associated to the organization in the initial years, let's say 10 years. This cross examination, this cross referencing between these two groups can itself highlight the necessity, the role of human cognition at workplace setting. So, when classical ergonomics was only talking about the quality of working, there were many unaddressed issues were there. Now, cognitive ergonomics was trying to address is not only to look at the quality of work, but also at the outcome. The outcome as a result of a person and a person who is doing a cognition and a cognition which is being done through various skills and abilities. And this cognition is a part of everyday life. So, what we understand with this cartoon, at least one thing, is that when at one hand classical ergonomics was talking only about the quality of work, cognitive ergonomics is trying to address the importance and relevance of human cognition. More importantly, how the cognition is going to alter the performance and efficiency of an individual. Now, this cartoon, what you see on your screen, at the center you see the engineering psychology, on your left hand side cognitive engineering, and on your right hand side ergonomics, and at the bottom human factor. Around this you see several sub-disciplines. What does it highlight? It highlights the significance, relevance of the discipline cognitive in engineering, the role of human factor, the role of human beings, and various parameters and variables associated with human beings here. So, on one hand you see the biological psychology is there, whose emphasis is upon to understand the biological processes in the underlying human behavior. Experimental psychology, to study and do experiments in a controlled environment to understand the underlying root cause of a human behavior. Similarly, social psychology, personality psychology, industrial psychology, industrial engineering. Alone, what you see on this screen, alone one discipline cannot address the question of human factor ergonomics. So a multidisciplinary approach, or multidisciplines are being involved here, and this discipline of cognitive ergonomics clearly indicates that it requires an interdisciplinary approach. The domain where it is being heavily used is aeronautical engineering, computer science, nuclear power plant, information transportation system, etc. and etc. In recent years, in-depth understanding we are having it about the human cognition and the role of human cognition at workplace setting and in human factors. Now, what can we aim, and what cognitive ergonomics is aiming to address is to understand how work is affecting the mind, how work is modulating, changing the mental processes, to what extent it shapes your mind, to what extent it provides you an easiness to change yourself and adjust according to the environment. Similarly, the mind, your own skills, abilities, your thought processes affects the work which you are doing. The way a lecturer drives a car will be very distinct than a driver driving a car. The thought processes of an individual with a specific discipline and expertise, his or her approach will be distinct from the other person. This inter-individual differences has been well documented in the discipline of ergonomics and also in cognition research. But what is more important for us to understand that how the work and the mind influencing each other, and how the interaction between these two influences the performance, efficiency, safety and the satisfaction of the user. What kind of information is required to make a decision? What kind of information is necessary to make a decision? When an individual is having large amount of time, then his or her decision making can reach to 100% accuracy. However, when the individual is having time stress, limited time, then the decision making not only need to be accurate but also has to be quick. Such a skill not everybody is born with, but over a period of time with regular practice and more experiences, one overcomes such challenges. The individual learn what kind of information required to be processed quickly and what kind of information required to be processed late. Also, the early and late selection of this information plays a crucial role in the preferential list, how an individual make a priority of his own work, which we have been doing it since our childhood. Then another factor which cognitive ergonomics is aiming at is the cognitive task analysis. Now we know the analysis of the task, any task. The task like getting a glass of water from a water cooler or from a fridge, or cooking or baking a chapati. It requires certain analysis to it. Task analysis initially was addressing mostly about the behavioral task analysis, the behavior of an individual. However, what it was not addressing is the skill and abilities which an individual possesses. This skill and abilities is playing a crucial role in task analysis. Hence, in recent years, cognitive task analysis seems to be highly relevant because it provides an in-depth understanding, not only in the collection of the data, identification of the knowledge, applying the knowledge, analyzing and verification of the data set, and formatting the data set. So, in recent years, people have started paying more attention towards the cognitive task analysis. In some domains, in some ergonomics discipline, people are even studying this as forensic task analysis. Different people have different approaches, but in this course, our main concern will be cognitive task analysis. Then, cognitive ergonomics also addresses a very simple problem: how to present the information. In front of you, I am presenting you the information in a textual form. In some cases, I will be presenting you information in a graphical form. The presentation of information need to be textual, graphical, verbal, non-verbal. That an individual has to decide it, which is more effective. Under certain circumstances, verbal is enough, and under certain circumstances, non-verbal is enough. Then, allocation of functions and mental workload. What kind of functions we are allocating and the type of mental workload we are facing. Mental processes itself is an ambiguous and complex in nature. So, the workload related to mental processes will obviously be ambiguous and complex in nature. Cognitive ergonomics can help us in providing deeper insight about the nature of the workload and its own classification and division. Now, the seventh point is the decision aids. When somebody has to make a decision, how he can get an aid. For instance, crossing a road, the individual requires some aid. Cognitive ergonomics can not only provide you the perceptual information, memory information, but also understanding the need of mental processes. Such decision aids can be textual, graphical, or could have any other sensory data information. Then, cognitive ergonomics can also help us in designing the cognitive system, the cognitive machines, the machines which can do their own task, the machines which can execute the stages of n number of stages of processes by themselves, which involve least human interaction, which involves least human interferences, and provide us the result with 100% accuracy. And finally, the usability, design and evaluation. The designs which user can use it with easiness, and also it can help us in understanding the shortcomings of the design as well. Finally, it can also reflect upon the inter-individual differences, the national level in context, and the cultural effects, how different culture are playing role and impacting the ergonomics. All these things we will be addressing it in coming lectures about the skills and abilities. Taking a little forward and discussing about how cognitive ergonomics is aiming and trying to address the problem. So one such thing is the how the work affects the mind. The work is stressful, it changes the way you think, the way you process information. Reaching the deadline for some individual is common, but for some individual it may lead towards anxiety disorder. Balancing the demand of work and life, personal and professional life, is a challenging task. So such effects we have to also see that if the work is affecting the mind is for short duration, it is okay, because a short duration effect can be overcome. But a long term effect may lead towards clinical disorder. And not only leads towards a clinical disorder, but it may impact the person's or individual life in a tremendous way. It may lead towards sleeping disorder, nervousness, anxiety disorder, etc. In a long-term effect, it may also promote the human error. Examples what we see in relation to thinking, reasoning, understanding, diagnosis, memory heuristics, etc. Such places we have seen when the workplace stress affects your mind in a robust way. The short-term effects can be overcome with some help, with some aid. However, the long-term effect requires a radical solution. Now, when we see the application of cognitive ergonomics, we see that there are three planes to cognitive ergonomics. First plane is human itself. The word cognition is there. Without human being, there cannot be a cognition. Without human beings, there cannot be ergonomics as well. So the first wall of support is human characteristics. What human characteristics we are referring here? The human characteristics which we are referring here is the human cognition, his cognitive abilities. Then the human interaction with the machine or a system, we require a technological context, what you see on the another wall. And then ultimately the human interacting within technology, he needs a context. So that is an organizational context. It could be a classroom, it could be office, it could be a nuclear lab, it could be a biosciences and bioengineering lab, it could be a cockpit of a plane. And when all the three things come together, then it leads towards the human action. So this is how the cognitive ergonomics is interacting. And in this cartoon, one thing it is very important for us to understand, there is no superiority effect of any one contributing factor. All factors are superior in nature and all factors are inferior in nature. the contribution by each of these factors are the deciding factors in cognitive ergonomics. It helps us in designing and the tools and the usage of the tools. The tools which you can find it in your garden, the tools which you can find it in your kitchen, the tools which you can find it in your labs. How to design these tools and how to make use of these tools in such a way that humans may have an advantage. It may help and promote the performance, it may help and promote the safety, and it may help and promote the user satisfaction. Cognitive ergonomics not only help in designing the workplace setting, but also uplifting the workplace situation, the employee's expectation, the employee's need. And more importantly, it is also highlighting the reliability of human cognition. 200 passengers in an aeroplane rely on the cognition of the pilot. A pilot relies on the cognition of the machine when he sets the system on autopilot. 300 passengers in a train rely on the cognition of the driver. Train driver relies on the cognition of the automated system. So, cognitive ergonomics is trying to unfold these layers of human cognition and trying to highlight the reliability of human cognition. In coming lecture series, we are also going to understand what different type of cognition we are paying more attention to. Human cognition, reliability of human cognition can be seen as two different ways. Reliability of basic human cognition and reliability of high level cognition. Basic level cognition, what do we mean with that? Attention, perception, memory. High level of cognition, reasoning, problem solving, decision making, etc. When a human interacts with the system, as you can see on your cartoon, taking an example of from the aviation, when a plane is flying, then the pilot in the air, the traffic controller on the ground, they need coordination. They both are interacting with their own machine system, and both systems are interacting with themselves. The stake of 200 lives is in the hand of two important people, air traffic controller and the pilot. Now what do you see? The control panel is there. Pilot should be aware of it, how to use it, how to land the plane, how to fly the aeroplane, what is the altitude at which he has to keep the plane, when he has to descend, when he has to reach the ground, when he has to accelerate up in the sky. The different stimuli are there which pilot has to encounter. Some could be visual in nature, some could be auditory, some could be tactile, and some could be olfactory as well. Along with that, the coordination between the pilot, air traffic controller, along with other pilots and other traffic controllers is a teamwork. Even a slightest of error a slight delay in information processing, a slight delay in information exchange may result into a severe accident. Then there are certain company policies, communication is there, noise, weather, is it a clean weather, is it a daytime or nighttime. As I showed you in previous slide, the period of 1 p.m., 1 a.m. to 3 a.m. in the morning, where more number of human errors are happening, the pilots are flying planes during that period as well. Are they stressed? Are they relaxed? Are they fully aware? Do they have any physiological, psychological, or cognitive or motor problem? Are those problems visible? Are those problems hidden? All these things matter. And that is why the pilots, the traffic controllers, from time to time, they undergo into a refresher course where they are exposed again and again to their skills and to enhance their capabilities and abilities. What we see here is the interaction of so many factors are there. You can see simple aviation, taking off a plane. You all might have experienced, your relative or even you might have taken a plane. And if you see this cartoon, you may understand it's such a complex task and requires a teamwork to work together in a harmony. If there will not be a harmony, then it might result into human error. Now what we see here, a personal and external factors are there. Intrinsic, some factors could be indirect, some factors could be direct. Intrinsic, extrinsic factors are there. Organizational setting, where the pilot or the person is working. Local working conditions. Is he being provided with resources? Is he being provided with support? And then the defenses, barriers and safeguards. How he can safeguard himself. What kind of coping mechanism he needs to solve his personal matters or to solve his professional matters. So these factors are also a contributing factor in an individual. A pilot who is flying, the staff who is assisting the passengers, and the passengers itself. So what we see here, that in an aviation, when a pilot is flying a plane along with 200 plus passengers, there he has to be in a sound mind. Now, what I would like to share with you here, there are two pictures which I would like to show you. First picture is on your screen, picture A. And in this picture, what do you see? Is a metallic frame, seems to be a small window. But what does it reflect? What does it represent? Or another picture on your screen, which is quite obvious, a door. What do you see here? Is a blue color door. If I ask you, what is the problem in these two big images, then the answer should be simple and easy. But for some, it is difficult to identify the problem. I have seen this image a number of times and I have used it, so it is easy for me to highlight the problem. But what you see on your screen, one side, picture A, is a petrol tank, petrol or diesel tank of a car. And the second image is a door, a simple door of a conference hall, a simple door of your house, a simple door of a marriage hall, probably. What is the problem in these two? In the first image, the petrol tank or the diesel tank in a car, we do not know which side we have to press. The arrow is indicating that if you press this side, then it will open. However, if arrow is not shown on your screen, then it becomes little difficult for you to identify where, on which side the petrol tank will open. Even not only this, which side it will be opening, but is it a petrol car or a diesel car? So if you see in your neighborhood, you will find some people put a sticker, a visual representation, a sticker with a letter P on it, or a sticker with a letter D on it. D represents diesel, P represents petrol. And now the educated or uneducated person, whosoever is there at the gas station, can see this symbol and identify if it is a petrol car or a diesel car. The educated and uneducated person, the uneducated person, for instance, doesn't have to know the letter itself. He can just see a representation, the letter P, and understand that it's a petrol car, because the representation of P of petrol starts with P, horizontal line and semicircle. The another image, what do we see is the see-through window is missing. Another challenge, to which side is it going to open? So somebody who is coming from the other end and somebody walking from this end may collide and an accident can occur. These are such simple designs which we see every now and then in our society. With these designs, can you say that your world is very well designed? No, the world is poorly designed, as said by many researchers and many designers. And we are making an attempt to understand such challenges and how to address these challenges. So, to conclude lecture 2, few things we have to note down here: the application of cognitive ergonomics, the aim of cognitive ergonomics, how much do we understand its contribution in the discipline of ergonomics, the role of human cognition, and how the biocircadian cycle leads towards the human error, and how the teamwork influences the human efficiency, performance, how in the aviation industry or in any other industry the significance and role of cognition is there.